Welcome everybody, welcome to another video by Flat Earth Philosophy, narrated by Papa Fliff. Everything's Flat Earth here, everything to do with philosophy as well. Today, off the cuff, nothing organised, just thought I would expand on the how the stars rotate in our night sky on this Flat Earth design. People aren't understanding what I'm saying, so I thought I'd draw it from another perspective. So we'll go over it. So imagine, first of all, you need to understand the toroidal field of Earth. We're all in this toroidal field, right? And Earth is the flat plane of inertia through the middle of it. Earth is from the hole. So you can imagine the black hole, and down and through a void, there's nothing going on. All the action's around the perimeter, horizon. In the hole itself, it's at rest. Earth is at rest, but the toroidal field, the vortex around it, is moving, forever moving. It's the toroidal field. Earth doesn't spin like a ball, no. This is it. What's coming out of the centre is all this energy, this electromagnetic field. It's like the pulse of an explosion. The instant, like we could all exist in an instant. Or Earth was created in an instant, whatever. But it's forever flowing out from the centre of the torus field, isn't it? So this is the ether, basically ether, right? But science, Einstein and all them, just the club members, the Freakmasons I call them, who run the whole show, decided to do away with ether and rename it dark energy, and then give themselves Nobel Prizes. Same thing, it's all forever flowing out of here. They want you to think it happened billions of years ago in the Big Bang. It's coming out of here every minute of the day, flowing over us. This is what drives the whole celestial system. The sun moving around. You've got the equator, you've got an equator right through that centre, halfway around here. It's a tropical gap, because that's our physical realm. That physical gap, that gap there, represents the dead centre of the vortex in here, the black hole. It's basically a point of nothing. Look, it merges to nothing in here. And it's been expanded out here, blown out into a massive image that we all live in. So we're inside this electromagnetic field, this pulse, you could say, that's forever flowing. So I realise dark energy that comes out of here every minute of the day. It's the ether, the magnetic field of Earth. And the magnetic fields of Earth flow out from the south to the tropics. They flow out from the centre of the toroidal field, the vortex, out to the tropics. The southern field is a parabolic image of the internal northern hemisphere. This is what people have to get their head around. They don't understand this. For a flowing toroidal field, there has to be an equator, because you've got all this action in here coming out of there, has to have a potential difference with the outer field to be rushing to each other. Otherwise it's stagnant. There's got to be the difference, electrical potential difference we know in electrical engineering, or computers, electronics. This is what the equator is doing on our flat Earth. That's the EMF in there. And that's that EMF that gets created in there, the magnetic field, the EMF, look up all that stuff, that gets sucked into this powerful vortex, which feeds into the sun. The sun is created in there due to this EMF. It gives you the spark, the voltage in our electrical system. It's all based on EMF. Your cables, your power station that's at the other end of the country, it's not one line all the way from north to south. There's a break in the line, there's breaks in the line. It's that EMF that actually creates the energy, the power. So all our free energy comes from EMF. It's all been hidden from us, of course. So you need to understand this. Ether, dark energy. But the Freakmasons give themselves Nobel Prizes when they rename it ether. When all along everyone knew it was, when they named it the dark energy, when all along, right through history, It's always been known as the ether. It was the ether moving in the Globebusters movie. What was it called? Beyond the Curve. You know, gyro compasses, they still follow the magnetic field of Earth. Gyro, laser, whatever. It's all, lasers are more moving of electrons. But gyro compasses and all that, normal compasses, they all follow the curving magnetic field of Earth. And it's curving laterally across our Earth. But as above, so below. So you've got the curve up here, the meridian, from north to south. You also have that distance equates to the curving magnetic fields looking down on Earth, horizontally. This is how they work out the size of it. It's measured as a sphere, they say. But it's not a complete sphere. It's deep, you've got to think. Done lots of videos on this. But anyway, this video here is about trying to show you how the northern hemisphere star rotation creates a parabolic image out to the south. Remember the two electrical potentials? The same energy is in here as it is out here, but look, this is more dispersed. So all our stars are all dispersed out here too, spread out more than what's in here. But the stars that are in the centre rotating around Polaris are the stars turning out here. So as this turns, you'll get a rotation out here. As it turns, you get a rotation out here. There's always a rotation out here because it's all coming from the centre. So if I draw it this way, for now we'll go northern hemisphere, star rotations, Polaris. And we'll say that's the toroidal field all the way around, like I've just showed you with that ducting there. Okay? But you know, down here, there's the equator. So we have south, north, north, south, right? South, south, north, north. Like that, okay? Or south, southern hemisphere, northern hemisphere, northern hemisphere, southern hemisphere. You've got the equator there and there. So we look at it this way. You've got the northern rotation there, Polaris, and the sun's down here in the black hole. That's the sun straight up there to Polaris. You can say it's made up of 3 stars if you want, because you've got the sun here, you've got the black hole there, and you've got, what have you got? Mercury and Venus close to the sun, haven't you? And what have you got out in Sigma Octantis rotation? It's the same thing, because Sigma Octantis is Polaris, is the sun. You've got to be a real good thinker to realise what I'm saying here, but just follow through. Okay, so you've got your star rotation there, and it's a parabolic image out here. Understanding parabolic mirrors, curved mirrors, what you get in a reflection. It's a 180 degree flip. So this rotation will create an opposite rotation on this curve. I've shown you the toroidal field, the curving. You know, in the encyclopedia, 1958 Encyclopedia Britannica, they tell you the firmament is 1,300,000 feet out at the south, out in the south. So they're hitting it close out here. This is 10,000 kilometres up here, but they're hitting it way down here. Okay? If you can understand, it's sort of more like this, because that goes like that, makes a nice symmetrical arc, and that goes like that. So they're hitting it, they found it 1,300 feet out south here. So first you've got to understand parabolic reflections. Okay, so that creates this rotation out here in the south. Sigma Octantis. That's one way of looking at it, right? Now, this is what I wanted to show you. Get rid of that. And we'll go, get rid of that, that. And we'll go north. So this is the northern this is the northern rotation. All the stars, all rotating around here. They don't drift off. although they may only do a certain turn, because you're looking down a vortex that goes like this, or like this. So this star here is going to disappear when it comes around the back. Like if it's in front of you here, it's going to disappear as it goes around there. So they only go so far and then disappear, and another star will come in. Another star out of here will come in. This is why there's always a rotation, because there's a rotation here already. If you lived on a spinning ball Earth, how can you have a rotation within 5 minutes of filming? Your spinning ball's only moved 5 minutes, hasn't even moved 15 degrees for an hour. You can't have a full rotation within an hour or any time. You'd have to, if you lived on a ball, it'd have to spin 360 degrees the whole day to get one rotation. So it's all lies. Absolutely. You have to be really dumb to believe you live on a ball. So you've already got a circular rotation here. This is why we always get a circular rotation, no matter how long you film it for. Everything is out of here. It shoots up and shows you Polaris up here. So anyway, with this model here, we'll go north. Now what have we done? We'll say this is north then, and we'll say this is south. And then you have your rotation out here. Now, and then this will be the equator, right? There's a gap between here, the celestial equator, there's a gap in the sky, and that's where Orion's belt comes through. Beautiful straight line across your horizon at night. And it keeps going, flowing through here for 9 months of the year, until the sun catches up to it. The sun eventually catches up to it, and we lose sight of it for 3 months, because everything's moving around the celestial equator. Nothing moves quicker than the sun. It's at the center of the energy field. It's in the center of the whole energy field. How could anything outside it move quicker than the product of the energy? So it's the sun always catching up. So over a whole year, they're all moving slowly, but the sun is slightly quicker. So what the sun does over a whole year is it laps the whole stars, one cycle. And science tells you it's the other way around. Let's not let go there. And that's exactly what the sun is doing each month with the moon. It laps the moon to come back. The moon is the one doing the faster travelling. Don't believe the spinning ball bullshit. So, I mean, they can't even explain this on their spinning ball. Why you see that at the celestial equator for a complete 9 months. You only see the sun there for a couple of days at the equinox, dead centre where that is. Then it moves on, because we get the tilting of the magnetic fields. That's a seasonal change. That's declination. That's different again. But anyway, back to the stars. So what we're seeing is the celestial equator here, the southern hemisphere, and the northern star rotation around Polaris. This is around Sigma Octantis, okay? Very faint out here because there's a parabolic image of that. So what's happening, if you're out south, say I'm here in New Zealand, I'll be looking directly north. I will see a little bit of the northern horizon, say here. So if I see a star, I can align this star directly north to south and find a formation here that will equate to that picture. And what do we have? Ursa Major. What do we have way back here? The stars in the constellation of Virgo. Because I'm in a straight line. That's when you'll get them the same. But if you're looking slightly east or west, whatever I see over here will appear in the southern hemisphere over this side. And what I see over there in the northern hemisphere will appear over this side. That's what happens, the parabolic reflection from this to this, north to south. Okay? Two examples are Ursa Major, Virgo, and what I found was from the southern hemisphere we see Orion's belt upside down. So I see Orion's bow like this. Bow, nice clean bow. So diagonally across in the southern hemisphere there'll be a big image of a bow. Faint, you need binoculars, and even then when you find it, it's hard to find it again. The southern hemisphere stars are exactly the same stars as the northern hemisphere because it all comes from the one place of creation, the center vortex. All the stars are in there. To go deep into science, it's all about iron. What flows in a magnetic field? The iron helps the magnetic field flow. It's something to do with iron in the higher atmosphere. It's what drives the magnetic field maybe, I don't know. But anyway, it's all being spun out of here. But mainly due to the recycling of Earth, the way the system works. Not got time to do that. Maybe, maybe not. But the magnetic field is flowing. The sun, once the sun is created, the voltage, the energy field flows. The circuit is created, and so the electricity is flowing through the line. It just keeps going. While that spark is there, the voltage is there, it's continuously flowing. So was that easy? Now, there's a second go at this video. I put one up and then quickly put it down. I didn't check it before I put it up online. I missed a few things like correlating the ether with the dark energy, and the fact that when I initially started, that was the northern hemisphere to there, so you had north there and south, north there and south. So I've had another go at it. I hope I haven't missed anything out. But that's basically it, everybody. The stars, these stars are the northern, is a parabolic image of the north. And they don't do a full rotation, they only go so far and then disappear, and another one swings in because it's always swinging in from this rotation. Okay, that's always turning. And the fact is, what's happening is, oh, that's what I missed, is this southern rotation is always moving around the northern hemisphere. It's like two cogs. It's a big cog turning. As this turns, it turns this all the way around. So no matter where you are out south, there's always a picture out south that you'll see centralized on Sigma Octantis, dead south, your north to south horizon. If you look to the west or the east, you'll see another rotation, but it won't be centralized. It'll be warped. Because if I'm in here, I've got this whole southern sky warped over my head as I'm looking north. But all I'm concerned about is this part here, this curve, and that curve there at the celestial equator when I'm filming star child photography. If I move the camera slightly east, I'll get another curve there. A bit more east, I'll get this curve way over here. Or if we go west, curve there, all related to this, or a curve there, which just goes to prove that the southern field rotates all the way around the northern hemisphere because it's a mirrored reflection from the center. No matter where you are, you see an image direct out. It won't be exactly the same as this guy. This guy won't be exactly the same as this guy, say, because it depends on the revolving of the stars, which star is out there as opposed to being over here. You look at this star, the other guy could be looking at the stars on this side, or over this side. Depends on where he is around the flat earth. It's quite straightforward, really, if you understand the proper model. This is what people aren't understanding. They're not getting their head around the proper model to then appreciate how it all works. So now, I've got a bit of time, I think. Let's check the video. Got 7 minutes. I'm flipping suffocating in here because warm air's. Windows closed so the neighbours don't hear me raving on. The energy, let's say the sun's in here, okay, it's been created in the vortex. Oh, the other thing is the Milky Way. I didn't draw the Milky Way. So you've got the complete vortex in here, but you've got the Milky Way. It's like the cross circuit. The pressure's built up and gone bang, it cross circuited, and then that created the sun, and the black hole is there. So the Milky Way seen in the night sky, it comes from the centre, and it basically comes out like this. And the southern hemisphere is like this. And then it comes around like this. And then north to south it'll end up dead straight over you at zenith. And then it'll just keep curling around again. It keeps curling around that way. This is why you see the Southern Cross, the crux, out here, whichever way you want to draw it, ends up right up here. It moves, it swings up as it's going around. That's how it works. It's, you know, it swings back up, so I can see it right almost above me at 37 degrees south. It's not directly above me, nearly there at zenith, from being way out there. It can end up here because it swings like that. And this is what equatorial mounts can show you when you're tracking a star. They tend to do that because basically they're doing a cardinoid like this, except we don't see that happening. But then you've got to understand how you know it's only doing this. It's pretty deep, but you get your head around it, it all makes sense. Okay. Now some people here say they don't see the southern, the Milky Way. So the Milky Way will be way down here. They don't see it up here, right? Because there's all the reflection being projected out. So there's centre, so if you're farther north you don't see it around here maybe. It's further. I've got my head around that, why it's just only seen way out there, but I think you will find it if you're around here. You'll see it. It's faint. You've got to be at the right time of the night in a beautiful clear sky to see that. It'll come right back. It aims to the north. It's always aiming to the north at one end. Is it? Yeah, because it'll start off way around there, but you don't see it at this early evening at this point. You tend to see it more coming in like midnight and after midnight, coming right in there. Okay, you're losing it here because it's getting too far away. It's going out of your arc of horizon as it swings around. You know, it's going right round like that. And look, you're starting to show your magnetic fields again of Earth. Magnetic fields of Earth, run lines, Coriolis. They've got all sorts of names for it. You come up with a new name and go and let them know you're going to call it something else, and you win a Nobel Prize. Yeah. Or do away with something and rename it and you win a Nobel Prize, like ether to dark energy. But you've got to be a Freemason, of course. You've got to be a club member. So that's that. A bit of time left for the energy magnetic field. Got 3 minutes. Understanding how the field works. So you've got the tropical gap. It creates the EMF, the electrical potential between the tight magnetic field within the centre here and the wider disbursement out south here. So like a step down or a step up transformer. The electrical potential difference. There has to be a difference for A to race to B and B to race to south or south, north, whatever. Some earlier videos I've said that these are both the same, north and they are really the same, but even when you've got something the same on Earth, there's always a north or a south pole because Earth is a dual system. So there has to be a north system meeting the south system, and they meet at the tropics, meet here, so you could say that's, you know, north and south, and this energy going down through there and the energy going down through there creates this EMF, and that gets sucked back into the sun. Okay, so you've got a field comes out of the south, comes up and goes down here and across the ground and back up this way. Then you've got a field coming up this way, going down this way and across that way, and it comes up this way. And it's the negative Earth meeting the atmosphere, positive atmosphere, where you get all the auroras. Aurora borealis, and up in the northern hemisphere you've got the, Aurora borealis up here in these zones, and Australis borealis. Borealis, whatever. That's how the magnetic field works. It's all by the sun, coming through from the sun now, because the sun is the voltage. That keeps everything flowing. How can you live on a spinning ball with the sun voltage way up here, 93 million miles away? How does it create the magnetic field? Every electrical system has a magnetic field. You can't ignore the sun and say you've got your own centre sun in the middle of your spinning ball. You can't have two suns, two electrical systems. Electrical system creates a magnetic field. You know, it's just a no-brainer to be an electrical engineer or anything and think the sun's up there and not know all this. You've got to be pretty well. You know you're half brain dead, I'm telling you. It's all there. So, like, share and subscribe. Let's get the numbers up on the subscribe department.